In SEEP-W, there are only two material properties that need to be defined, a hydraulic conductivity function and a volumetric water content function. If you're going to model a steady-state problem, you only need to define a hydraulic conductivity function. If you are going to model a transient simulation where the pore water pressures in the ground will change with time, then you also need to define a volumetric water content function. These functions can be estimated by first defining a simple and easily measured grain size curve. The correct procedure is to define the grain size curve, then to use this curve to predict the volumetric water content function, and then to use the water content function to predict the hydraulic conductivity function. In SEEP-W, all functions are defined under the Key-In menu. For this demonstration, a grain size curve for a uniform fine-grained sand has already been defined. It's important to ensure that the curve is nicely defined and includes information regarding both the D10 and D60 of the soil. Once the grain size curve exists in SEEP, you can then use this curve to predict the volumetric water content function. Create a new function and click on the Estimate button at the top of the dialog box. There are 4 different estimation methods currently available in SEEP. 2 of the methods use the grain size function that's been defined, and 2 use closed-form function parameters. The theory behind all the methods available is presented in the SEEP-W engineering book, which is available in PDF format from the start page of GeoStudio. For this demonstration, we will use a method that is appropriate for predicting a water content function for a sandy soil. When estimating the water content function, you need to define the porosity of the soil. The porosity is equal to the volumetric water content at saturation. Use the drop-down list to select the grain size curve you want to use. And define a minimum and maximum pressure range for the function and how many points to include along this range. Depending on the type of analysis you're doing, you may need to define the coefficient of compressibility, which is the slope of the function in the positive pore water pressure range. However, if you're simply predicting this function in order to develop a conductivity function for a steady state analysis, defining an m sub v value may not be necessary. You can view the estimated function in either arithmetic or logarithmic scale. Now you can use this function to estimate the hydraulic conductivity function. We will predict the conductivity function using a method developed by Van Genuken. Define the saturated conductivity of the soil and the pressure range that you want to define the function over. You can make adjustments to the estimated function by using the graph manipulation tools available within SEEP-W. The saturated conductivity of the function can be easily adjusted simply by typing in a new value and then exiting the field, which will automatically adjust the function up or down as required.